All right. So we are just working our way down that trig chart. Today we're going to talk about the half angle formulas. Which are really just a variation on the double angle formulas. All right, so we're going to start off with cosine. Cosine 2 theta. The purpose of all these formulas is to be able to find the sine, cosine, and tangent of some angle that isn't on the unit circle. We started off with the sum and difference, then we did the double angle formula. Now we're going to do the half angle formula. So the idea is maybe you know the sine, cosine, tangent of some angle, but you've got something else that it's not exact, or it's not a nice 30, 60, 90, 120, 270 or anything like that. Somewhere in between there. And as we've seen before, having exact answers is really, really, really nice because, well, then it's exact. And you don't have any rounding and approximation errors. Okay? From yesterday we talked cosine 2 theta. There's actually 3 different formulas for that. What we're going to focus in on today is the formula that was the cosine squared one. So the way this works is that if you have cosine of 2 times some angle, that's equal to 2 times the cosine of that angle, the original angle itself, squared minus 1. We'll do a little bit of manipulation. What we're going to do is we're going to try to isolate this right here. So first thing, we'll add 1 to both sides. So cosine 2 theta plus 1 is 2 cosine squared theta. Then divide both sides by 2. I'm going to actually write this on the other side. So cosine squared theta is equal to cosine of 2 theta plus 1 all divided by 2. And then do square root. So cosine of theta is equal to, technically it's plus or minus the square root of cosine of 2 theta plus 1 all over 2. All right, that's one form of it. Another form, I'm actually going to go up to this step right here. Well, I think that's actually in your trig chart. What it calls these half angle formulas, it calls them the power reducing formulas. And if you see that very first one, I believe it says cosine squared u equals cosine 2u plus 1 over 2. So get out your trig chart, see if you can find that one. Okay. So you just need to realize these two things are identical. Well, they're not identical, but they are equivalent. So you can use this one if this is what you like. You can use that one over there if that's what you like. Just sort of depends. All right. Well, that's one of our 3 formulas for today. Here's the second one. We'll start off again with cosine 2 theta. Only this time we're going to use the other formula, or one of the other formulas, 1 minus 2 sine squared theta. And what we're going to want to isolate is that sine squared theta. So subtract 1 from both sides. So cosine 2 theta minus 1 is negative 2 sine squared theta. Divide both sides by negative 2. At the same time, we bring that sine squared, just write that over here on the left. So sine squared equals cosine of 2 theta minus 1 divided by negative 2. If you divide by a negative, actually we kind of talked about that there in the grading, we can switch the signs of those. So sine squared of theta equals 1 minus cosine 2 theta all over 2. And then just like we did down there, we can take the square root of both sides. So the sine of theta is equal to plus or minus the square root of 1 minus cosine 2 theta all over 2. If you look on your trig chart, they have, I believe it's this one, sine squared u. They have it as 1 minus or 1 minus cosine 2u all over 2. That's how they get that equation. So that's our our second of 3 today. And then tangent is going to be kind of strange here. Tangent of theta, remember that's can be written as sine over cosine. So we're going to take sine, which is this right here. We're just going to be concerned with our positive version here. So we've got, or well, I guess it's plus or minus the square root of 1 minus cosine 2 theta all over 2 divided by plus or minus the square root, pulling that one from over there, cosine 2 theta plus 1 all over 2. And so like all good fractions of fractions, we're going to write the numerator times the reciprocal of the denominator. So I've got plus or minus the square root of 1 minus cosine 2 theta. At the same time, I'm going to make a nice little change. And remember, if you have the square root of a fraction, you can just split that up into square root numerator, square root denominator. So times the reciprocal of the denominator. So square root of 2 over square root cosine 2 theta plus 1, plus or minus, obviously, that would be something like this. But the reason I do that is because that way the square roots cancel. And you have tangent of theta is equal to plus or minus square root 1 minus cosine 2 theta over 1 plus cosine 2 theta. Which I'm writing that just because there's the reordering that cosine 2 theta, so it's nice and interesting. But I don't think that's the way your trig chart has this formula written. I'm pretty sure they square both sides. Is that right? They say tangent squared u, maybe? Do they have 1 minus cosine 2u over 1 plus cosine 2u?
Yeah.
Okay. But I just want you to see that didn't come out of, nowhere. It's just originating from those formulas right there. Okay. And that's the third of 3. So let's do some problems together, shall we? So use a half angle identity to find the exact value of each expression. This cosine theta is 3 square roots of 7 over 8, and theta is between 0 and 90. Find the sine of theta over 2. Okay. Well, it doesn't hurt to draw a short little picture just to make sure we know what's going on. Which quadrant are we in here? Quadrant 1. So we're somewhere, up there for our theta. We could think of this as since this is cosine, and that's like the x value, and that could be the r value. So you could have 3 square roots of 7 and 8 right there, or it could be some multiple of that. It could be 6 square roots of 7 and 16, or multiply this by 3, 9 square roots of 7 and 24. It could be any of those. We're looking for the sine of theta over 2. Okay, so let's think about that. Which quadrant is half of this angle going to be in? Yeah, still in the first quadrant. So that's helpful for us because the sine in the first quadrant is so theta over 2 would be between 0 and 45. And the sine of theta over 2, the sine sin, or the sine of the sine, is going to be positive, I guess is what I'm getting at. Alright? So, we're like, alright, this looks really strange, Mr. Goddard, that sine of theta over 2, because you didn't tell us anything about sine of theta over 2. You just told us like the sine of theta. Okay? So you're like, wait, is there another formula that we're going to have to realize?
Is that why it's divided by 2?
And then what do I have to do? Well, not necessarily. See, like, what I want you to see is right over here. So, whatever number is here, okay, that's 2 theta. This over here is half of it. Okay? So, for instance, I could write this a slightly different way. I could write it like this. I could say, I got the sine, and I've got plus or minus the square root. I could put 1 minus cosine of theta right there, okay? And then what would be right over in this spot? Theta over 2. That's why in the lesson I call these the half angle identities, okay? Now, because you're taking, it's normally, you have some angle that you already know some properties of, and we're worried about taking the sine, cosine, or tangent of half of that angle. Okay, so, in that case, on our formula chart, it might not be a bad idea to rewrite this maybe off over in the margin. Another way you could write this as the sine squared of u over 2 is equal to 1 minus the cosine of u over 2. So actually there's a slightly different version, but that's not that different. So I'm going to give you a minute. If you want to make that modification for the sine, the cosine, and the tangent, while I take care of the tangents.
Oh, the tangent's already like that.
Tangent's already like that?
Mm-hmm.
Well, no, I wouldn't say so because this is.
No, and here it is.
No, cosine 2u.
You've got the 2u over here. I'm not talking about this version with the square roots. I'm talking about writing tangent squared of something is 1 minus cosine. If we say 2, or not 2 theta, just say theta, cosine theta, over 1 plus cosine theta, then inside this, whatever is the parameter of tangent squared, it has to be half of what's over here. So if we have theta over here, it would be theta over 2 right there. That's what I'm saying. Alright, so let's actually do this problem. So that being said, we'll write it down here. It'll be easier if you write it down every single time for every problem, because then when we have a memorization quiz, it'll already be in your head. So it's plus or minus the square root of 1 minus cosine theta all over 2. In this case, we've already determined, is it gonna be plus or is it gonna be minus?
Plus.
It's gonna be plus, because the first quadrant, sine in the first quadrant is positive. So it's positive, which means it should be blank completely. 1 minus 3 square roots of 7 over 8, all divided by 2. And I say, yuck, time to do some algebra on this. So, let's see. We've got two things here. We want to maybe combine those. We could write that as the square root of, 8 over 8 minus 3 root 7 over 8 over 2. So that numerator would be 8 minus 3 root 7 all over 8 all over 2. Then if you remember your fraction math, take the numerator times reciprocal of the denominator. So we've got square root 8 minus 3 square roots of 7 over 8 times the reciprocal of 2, so 1/2 square root 8 minus 3 square roots of 7 over 16. As we saw before, properties of square root, you can split this up into the square root of the numerator over the square root of the denominator. So that final answer is going to be square root, well, at least to this point, 8 minus 3 square roots of 7 over 4. And now you're looking at that and you say, whoa, square roots of square roots? That can't be right. That can't be, I don't know, the perfect final form.
Isn't that 8 over 8 in the third one?
It's 8 minus 3 square roots of 7 over 8.
Wait, no.
Is that 8 over 8? Yep. Because we turned that 1 into 8 over 8. Find that common denominator. Guess what? Final answer. Should we check it?
We already did. It was like 0.06.
So you did, okay. So enlighten us, gentlemen. How did you check this answer?
We found theta.
Found?
And then divided left side of theta to the positive.
Okay. So that's a good way of getting a decimal approximation. Does the calculator give you the exact answer?
Sometimes.
Well, I mean, is it gonna give you this? No, that's radical, it can't. But you, so this is what they did if you wanna be able to check your work. So we've got cosine of theta is 3 square root of 7 over 8. So you guys said you found theta as the inverse cosine? Okay, so run that for me one more time. So what just?
Was 7.2.
Give me 3 digits after the decimal.
7.180 or 181.
181 degrees. Okay. And so therefore half of that, so theta over 2 is 3 point.
Oh, we didn't do that.
You didn't do that?
We just left her answer.
You just put, oh, okay. You did sine of answer divided by 2. Sounds good to me. And what do you get with that?
0.063.
0.063. And then did you type this into the calculator? Okay. And so this is approximately, is it 0.063? Okay. So this is a way that you can check your work. There's no excuse for you to get anything, lower than a 100% on your homework in that case, because you can actually check and verify. Does anybody have a question about these steps which we did right here? Okay. Do you understand why this is not good enough. It is, yeah, it's not that good. And if you remember, one of the things that happens every time you have a rounded answer and you do something else with it, the error gets bigger. Let me give you an example. In my engineering class, they're working right now on these robots, and I said, okay, make your robot travel in a square. Okay, look up here real quick, back, folks. So, she seems pretty easy. Robot would start here, go straight, turn right, go straight, turn right, go straight, turn right, go straight, turn right. It's not that big of a deal, okay? It seems pretty straightforward, except for the fact that it's not straightforward because the robot has a difficult time going in a straight line. There's some problems in the differentials between the motors. If batteries aren't sending the same power to each motor, there's other problems. So some of the groups, their robot, they try to get in a straight line, it's ended up right here. And they've said, no big deal, let's just make it go in a square, okay? So they turn 90 degrees from right here, okay? And then if it went in a straight line, it would travel like this, okay? But it can't travel in a straight line. It travels kind of like this. You see where I'm going with this? And then it turns 90 degrees. If it would turn 90 degrees straight, then it would actually go like this, but it doesn't. It kind of goes like this. See where I'm coming from? And then if it were to turn 90 degrees, it would actually follow a long line. It'd probably end up here, which wouldn't be too bad, but instead it goes like, it kind of veers off a little bit to the right. Or to the left, I guess I should make it each time. To the left, to the left. So it ends up back right down there. And so the idea is that the error gets more and more and more each time. Here it actually wasn't too bad, right? Does that make sense? And so when you're doing calculations and designing systems and processes that are going to use this calculation for something else, which is going to use it for something else, then that error gets huge, and you need to be able to have the exact values there. Okay, let's speed this up a little bit. Number 2, is that any different from the first one? Oh, we've got sines and sines. Okay, so that's not too bad, I guess. Looking at, still got first quadrant, we still have this. So sine of theta over 2 is equal to plus or minus the square root. Now this is a problem because my formula only deals with cosine.
Can we just plug 3 over 5 for theta?
Can you just plug 3 over 5 for theta? Well, what's the formula? It's square root of. Is it 1 plus or 1 minus? 1 minus cosine theta all over 2. Okay, so we can't. The problem is we don't have cosine. We just have sine. Yeah, make the triangle. So 3 for the y. Hey, I know what that is. 4. Okay. It's a good old Pythagorean triple there. So, is this going to be plus or minus? Plus because we're first quadrant, okay? So, square root 1 minus cosine is 4 over 5. So 1 could be 5 over 5. So 1 minus 4/5 is 1/5 over 2. I like this one better than the other one, don't you? So I have 1/5 times the reciprocal. So I've got 1 over 2. So that's square root 1/10. Well, that's not good enough. I need to do square root of 1 over the square root of 10. Separate those. And then rationalize the denominator. So times the square root of 10. Square root of 10. So that's going to be 1 times root 10. So that's square root of 10 over 10. I thought this was supposed to get harder as we went along.
that bottom number? The root 10 over what? Root
10 over 10 over root 10. We're multiplying it in order to get, we're trying to rationalize the denominator right here.
Okay,
So-
I see.
What do you say we just skip these other ones and go straight to a tangent problem?
Yeah.
Okay? Although actually, let's hold off. I'm gonna go back on what I just said. Let's look at 3 and 4 very quickly and determine, go through that process. Is the answer gonna be positive or negative? Okay? Because that might be something that comes into play here. In this situation, we have cosine of theta is 24 over 25, and theta is between 270 and 360. So theta is down here now, okay? They want us to find theta over 2. So one way, a short way of doing that is we could just look at this inequality and say, okay, theta divided by 2 has to be between, divide everything by 2. So 360 divided by 2 is 180. What's 270 divided by 2? 135. Where does that put us?
Second part, no, third part. No, second.
Sorry, it's supposed to be less than. Second quadrant, yeah. So theta over 2 is somewhere between 135 and 180. If we're taking the cosine of something over here, is that going to be positive or negative? It's going to be negative. So just put in a little note there. You should have a negative answer, which means just stick the negative out in front of that square root symbol. Does anybody have a question about that? And that's just going to be the same process of algebraic simplification. Let's look at number 4, see if that's the same or different. The sine of theta is negative root 3 over 2, and we're between 270 and 360. Okay, so it's still somewhere over here. Of course sine is negative, it's in the 4th quadrant. Find cosine theta over 2, well, it's going to be the same thing.
Be negative.
Yeah, it's going to be between 135, so it's going to be, theta over 2 is going to be somewhere right around there. And since it's cosine of an angle in the 2nd quadrant, it's definitely going to be a negative answer. Okay, now we'll go to the back page. Alright, cosine of theta is negative root 5 over 5, and okay, this is interesting. Theta is between 180 and 270, so theta over 2 is going to be between 90 and 135. So between 90 and 135 is all right here. What's tangent going to be of that?
Negative.
It's going to be negative because why tangent second quadrant is always negative. So we're looking at something that's negative. All right, so let's write the formula down. Tangent of theta over 2 equals, oh, I erased it.
Minus cosine theta over 1 plus cosine theta.
Are y'all in agreement with that formula? There's no square roots?
Nope.
Now it's
Tangent square.
Yeah, we use that.
it's tangent squared of this. Okay, thank you. So therefore, just regular old tangent of theta over 2 would be plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. And since we know it's negative, we'll put the negative out front. So negative square root 1 minus negative root 5 over 5 over 1 plus negative root 5 over 5. Oh boy. Alright, so let's get going here on our algebra. So, minus negative, the same thing as positive. I want to find a common denominator, so I'm going to turn this into 5 over 5. So see if you can follow along with me. 5 plus square root of 5 all over 5 divided by, turn that 1 into 5 over 5. So 5 minus root 5 over 5. That square root is over all of that stuff. I'm doing several things at once, so make sure you understand all the different things I'm doing. I'm turning 1 into 5 over 5. And I'm noticing that I have a common denominator, so I'm combining the numerators, 5 plus, and then the denominator right there is still going to be 5. Does anybody have a question about that? This numerator to this numerator. Speak now. Okay, if you do, I'm here at lunch, 12:35. Now you know why I gave you so much room there on the bottom of the page. So, equals negative square root fractions of fractions. Keep the numerator, multiply it by the reciprocal of the denominator. So we have 5 plus square root of 5 over 5 times 5 over 5 minus square root of 5. Okay, that's great. Negative 5's cancel, so I have negative square root 5 plus root 5 over square root. I'll just make it like easy, put square root over all of it, I guess. Okay? But remember, you can split those up into negative square root of the numerator over square root of the denominator.
Did you get that?
How'd I get what?
The bottom.
It's just a property of square roots. The square root of a fraction is equal to a fraction of the square roots. So I'm going to multiply it. I want to get rid of this square root in the denominator. So notice, I'm not going to multiply it by the conjugate. I'm just going to multiply it by 5 minus root 5. Square root 5 minus square root of 5. Yes. Yeah, well, the system was down earlier. So, square root, we're going to have square root of 5 plus root 5. I'm going to put these in parentheses so we can see what's going on. 5 minus root 5 all over. We have the square root of blah times the square root of blah. The blahs are the same. So we've got 5 minus square root of 5. Up here I notice I've got a pattern A plus B times A minus B. So that's going to be A squared minus B squared. So 5 squared minus the square root of 5 squared. Yep, thanks. Negative up front. So now we've got 25 minus 5 all over 5 minus square root of 5. We're almost there. Hang in there. Square root of 20 over 5 minus root 5. Now we need to rationalize the denominator. Multiply 5 plus square root of 5. 5 plus square root of 5 gives me square root of 20 times 5 plus square root of 5 all over A minus B times A plus B is A squared, 25, minus 5, and you can, yeah, there's still that negative out front, thanks, yeah, Shelby, yeah, negative, and you can continue that through. Alright, let me give you the homework. Today we talked about the half angle formula. You have 2 days on this homework.